Aluminium oxide is a chemical compound of aluminium and oxygen with the chemical formula Al2O3. It is the most commonly occurring of several aluminium oxides, and specifically identified as aluminium oxide. It is commonly called alumina, and may also be called aloxide, aloxite, or alundum depending on particular forms or applications. It commonly occurs in its crystalline polymorphic phase alpha Al2O3, in which it composes the mineral corundum, varieties of which form the precious gemstones ruby and sapphire. Al2O3 is significant in its use to produce aluminium metal, as an abrasive owing to its hardness, and as a refractory material owing to its high melting point. Natural occurrence. Corundum is the most common naturally occurring crystalline form of aluminium oxide. Rubies and sapphires are gem-quality forms of corundum, which owe their characteristic colors to trace impurities. Rubies are given the characteristic deep red color and their laser qualities by traces of chromium. Sapphires come in different colors given by various other impurities, such as iron and titanium. Properties. Al2O3 is an electrical insulator but has a relatively high thermal conductivity for a ceramic material. Aluminium oxide is insoluble in water. In its most commonly occurring crystalline form, called corundum or alpha aluminium oxide, its hardness makes it suitable for use as an abrasive and as a component in cutting tools. Aluminium oxide is responsible for the resistance of metallic aluminium to weathering. This layer protects the metal from further oxidation. The thickness and properties of this oxide layer can be enhanced using a process called anodizing. A number of alloys, such as aluminium bronzes, exploit this property by including a proportion of aluminium in the alloy to enhance corrosion resistance. The aluminium oxide generated by anodizing is typically amorphous, but discharge-assisted oxidation processes such as plasma electrolytic oxidation result in a significant proportion of crystalline aluminium oxide in the coating, enhancing its hardness. Aluminium oxide was taken off the United States Environmental Protection Agency chemicals lists in 1988. Aluminium oxide is on EPA's toxics release inventory list if it is a fibrous form. Amphoteric nature. Aluminium oxide is an amphoteric substance, meaning it can react with both acids and bases, such as hydrofluoric acid and sodium hydroxide, acting as an acid with a base and a base with an acid, neutralizing the other and producing a salt. Al2O3 plus 6HF2 Al3 plus 3H2O Al2O3 plus 6NaOH plus 3H2O2 Na3Al6 structure. The most common form of crystalline aluminium oxide is known as corundum, which is the thermodynamically stable form. The oxygen ions nearly form a hexagonal close-packed structure with aluminium ions filling two-thirds of the octahedral interstices. Each Al3+ center is octahedral. In terms of its crystallography, corundum adopts a trigonal Bravais lattice with a space group of R3C. The primitive cell contains two formula units of aluminium oxide. Aluminium oxide also exists in other phases, including the cubic gamma and eta phases, the monoclinic theta phase, the hexagonal chi phase, the orthorhombic kappa phase and the delta phase that can be tetragonal or orthorhombic. Each has a unique crystal structure and properties. Cubic gamma Al2O3 has important technical applications. The so-called beta Al2O3 proved to be null. 11017. Molten aluminium oxide near the melting temperature is roughly two-thirds tetrahedral, and one-third 5-coordinated. Very little octahedral alloy is present. Around 80% of the oxygen atoms are shared among three or more alloy polyhedra, and the majority of interpolyhedral connections are corner sharing, with the remaining 10 to 20% being edge sharing. The breakdown of octahedra upon melting is accompanied by a relatively large volume increase. The density of the liquid close to its melting point is 2.93 grams per cc. Production. Aluminium hydroxide minerals are the main component of bauxite, the principal ore of aluminium. A mixture of the minerals comprise bauxite ore, including gibbsite, boehmite, and diaspore, along with impurities of iron oxides and hydroxides, quartz and clay minerals. Bauxites are found in laterites. Bauxite is purified by the Bayer process. Alo plus H2O plus NaOH null 4 Al3 plus NaOH null 4. Except for CO2, the other components of bauxite do not dissolve in base. Upon filtering the basic mixture, Fe2O3 is removed. When the Bayer liquor is cooled, Al3 precipitates, leaving the silicates in solution. Null 4 NaOH plus Al3. The solid Al3 gibbsite is then calcined to give aluminium oxide. 2 Al3 Al2O3 plus 3 H2O. The product aluminium oxide tends to be multiphase, i.e., consisting of several phases of aluminium oxide rather than solely corundum. The production process can therefore be optimized to produce a tailored product. The type of phases present affects, for example, the solubility and pore structure of the aluminium oxide product, which, in turn, affects the cost of aluminium production and pollution control. For its application as an electrical insulator in integrated circuits, where conformal growth of thin film is a prerequisite and the preferred growth mode is atomic layer deposition, Al2O3 films were prepared by the chemical exchange between trimethyl aluminum Al3 and H2O. 2Al3 plus 3H2O Al2O3 plus 6CH4H2O. In the above reaction was subsequently replaced by ozone as the active oxidant, and the following reaction took place. 2Al3 plus O3 Al2O3 plus 3C2H6. The Al2O3 films prepared using O3 show 10 to 100 times lower leakage current density compared with those prepared by H2O. Known as aluminium or alloxite in the mining, ceramic, and material science communities, aluminium oxide finds wide use. Annual world production of aluminium oxide in 2014 was approximately 108 million tons, over 95% of which is used in the manufacture of aluminium metal. The major uses of specialty aluminium oxides are in refractories, ceramics, polishing and abrasive applications. Large tonnages of aluminium hydroxide, from which alumina is derived, are used in the manufacture of zeolites, coating titania pigments, and as a fire retardant, smoke suppressant applications. The great majority of aluminium oxide is consumed for the production of aluminium, usually by the Hall-Héroult process. Filler being fairly chemically inert and white, aluminium oxide is a favored filler for plastics. Aluminium oxide is a common ingredient in sunscreen and is sometimes present in cosmetics such as blush, lipstick, and nail polish. Glass. Many formulations of glass have aluminium oxide as an ingredient. Catalysis. Aluminium oxide catalyses a variety of reactions that are useful industrially. In its largest scale application, aluminium oxide is the catalyst in the Claus process for converting hydrogen sulfide waste gases into elemental sulfur in refineries. It is also useful for dehydration of alcohols to alkenes. Aluminium oxide serves as a catalyst support for many industrial catalysts, such as those used in hydrodesulfurization and some Ziegler-Natta polymerizations. Purification. Aluminium oxide is widely used to remove water from gas streams. Other major applications are described below. Abrasive. Aluminium oxide is used for its hardness and strength. It is widely used as an abrasive, including as a much less expensive substitute for industrial diamond. Many types of sandpaper use aluminium oxide crystals. In addition, its low heat retention and low specific heat make it widely used in grinding operations, particularly cut-off tools. As the powdery abrasive mineral alloxite, it is a major component, along with silica, of the Q-tip chalk used in billiards. Aluminium oxide powder is used in some CD, DVD polishing and scratch repair kits. Its polishing qualities are also behind its use in toothpaste. Aluminium oxide can be grown as a coating on aluminium by anodizing or by plasma electrolytic oxidation. Both its hardness and abrasive characteristics originate from the high strength of aluminium oxide. Paint aluminium oxide flakes are used in paint for reflective, decorative effects, such as in the automotive or cosmetic industries. Composite fiber aluminium oxide has been used in a few experimental and commercial fiber materials for high-performance applications. Alumina nanofibers in particular have become a research field of interest. Abrasion protection alumina is used to manufacture tiles which are attached inside pulverized fuel lines and flue gas ducting on coal-fired power stations to protect high wear areas. They are not suitable for areas with high impact forces as these tiles are brittle and susceptible to breakage. In lighting, transparent aluminium oxide is used in some sodium vapor lamps. Aluminium oxide is also used in preparation of coating suspensions in compact fluorescent lamps. In chemistry laboratories, aluminium oxide is a medium for chromatography, available in basic, acidic and neutral formulations. Health and medical applications include it as a material in hip replacements. As well, it is used as a dosimeter for radiation protection and therapy applications for its optically stimulated luminescence properties. Aluminium oxide is an electrical insulator used as a substrate for integrated circuits but also as a tunnel barrier for the fabrication of superconducting devices such as single-electron transistors and superconducting quantum interference devices. Insulation for high-temperature furnaces is often manufactured from aluminium oxide. Sometimes the insulation has varying percentages of silica depending on the temperature rating of the material. The insulation can be made in blanket, board, brick and loose fiber forms for various application requirements. Small pieces of aluminium oxide are often used as boiling chips in chemistry. It is also used to make spark plug insulators. Using a plasma spray process and mixed with titania, it is coated onto the braking surface of some bicycle rims to provide abrasion and wear resistance. Most ceramic eyes on fishing rods are circular rings made from aluminum oxide.